Hi, so this is going to be part 4 of my AeroSense IT/OT project, and in this part I'm going to explain how I've set up the Kafka publisher, the sensor mapper, and the schemas. So before explaining my code, I'll just give a walkthrough of how Kafka basically works. So Kafka has three main parts. That's the producer, the broker, and the consumer. So the producer, it takes the values from VBots, it make it into a structured format. It will check for all the mandatory and non-mandatory values like the keys, values, timestamps, etc. And if everything looks good, it will be converted into raw bytes or it will be serialized. So this serialized value will be sent out via TCP onto the broker. So instead of sending each value one by one, we have an option to have a buffer in the producer. So buffer basically collects the byte streams till it reaches a particular size, and then once it's batched it will be sent over the TCP onto the broker. So this increases the efficiency because it reduces the number of IO calls required in order to send the data. And coming to the broker has a leader broker and a follower broker. So there could be multiple follower brokers as well. So the leader broker first collect the data, and the follower brokers poll the leader and takes a copy of the byte stream and keep it with themselves. So, and it will have to send back an acknowledgement as well. So with respect to acknowledgement, there are three ways to go about this. So either acknowledgement can be zero. This means the producer just sends the data and move on. That's it. It won't wait for any acknowledgement. It can be one. It means the leader broker will send back an acknowledgement once it receives the complete data, or it can be all. It basically means all. Uh, Basically, it will wait for all the follower brokers to get the data until an acknowledgement is sent, and this is considered as a slower option out of the three. So we'll just keep it back to one. And the data will be stored inside something called a topic, and a topic can be easily compared to as a file inside a file system, basically to group our streams into one place. And the third part is the consumer. Consumer basically pulls the data from the brokers. So instead of the broker pushing the data, it will just keep holding onto the data for a predefined set of time, let's say 7 days or 1 day, and the consumer just pulls the data from the broker. So even if one consumer fails, okay, there is another option called an offset. So basically, once the consumer pulls the data, and it's basically an acknowledgement from the consumer that till a particular section the data has been received, and if a consumer fails it can restart again and start polling from the place which has left off. Okay, so this is basically how the Kafka works. And now onto my code, I have imported struct log. This is for structure logging, Kafka exception for Kafka related errors, Kafka error for messages or the error acknowledgement related errors, and the producer is basically what generates the data, and the buffer error is for the buffer inside the producer. So this settings is basically the variables, Kafka related variables that I've saved in the settings file, and this is where I've defined the producer and the delivery report as well. Like I have used extensive logging here because it'll be really easy to isolate an issue or in order to find where the system has failed. So if the message has failed, then the topic and the error will be logged. And if it's been successfully delivered, then the partition, the offset, and the topic will be logged. So with respect to the uh, sending the payload, I've kept it as a try except uh, loop because respective of the message being sent out or not, the uh, the simulation should work. The simulation shouldn't fail. Like all these parts are isolated. So in the try loop, I've set the payload. This is what the bunch of the data or the dump of the data looks like. And this is the identifier and it'll be encoded in UTF-8 as well. So uh, we'll be defining the topic, uh, the key bytes, the payload, that's the whole stream, and the delivery report. So the buffer error is for the buffer that I mentioned earlier, and the flush is for, let's say, the stream has ended, but we cannot shut down Kafka abruptly because there might be still values yet to be sent on the buffer. So flush basically waits for all the messages to be sent out and then it shut down Kafka. Okay, so now on to the sensor mapper. In the sensor mapper, this is basically how the telemetry data structure is defined. So I have added the camera metadata here. Again, as I've said in my previous video, if the camera part is not relevant, it can be ignored. So in the camera metadata, I'm importing or collecting three values: brightness, motion blur, and object count, all in floats. So brightness, it's basically the mean mean brightness value of all the pixels inside the image. And I'm converting the image to grayscale as well. And with respect to motion blur, it's the difference between the previous image and the current image mean. And for the object count, I've defined it as a separate function because this is a bit long. So basically what I'm doing here is I'm checking for spots in the image with a higher mean intensity compared to the surroundings. And if that spot has a particular size or greater, it will be considered as an object. And also so that each object won't be counted twice, we'll be logging the values if it's visited or not. If it's already visited, then it'll be ignored, and if it's not, it'll be a new object in the image. With respect to the telemetry, you can see here this is all the values that I'm collecting. And for GPS, IMU, gyro, and compass, you can see that I've set it up as tuples. So tuples because I need the values to be immutable, and the order should also not change. So if you look here, the roll, pitch, and yaw, that's what's combined into IMU, position XYZ into the position, lat, longitude, and altitude for the GPS, and this is basically how the payload will look like. And to enforce the data types, I've defined the schema here, and this is the one place where the schema is defined, and this will be used for testing during runtime, validation, and in the bridge as well. So I've used Pydantic for enforcing the data types. I'm using the Pydantic's base model, and basically I'm enforcing X, Y, Z, the positions to be float values, and this field, it basically defines the value range which is permissible. It should be greater than or equal to 0, and it should be less than or equal to 500. So if the drone is still on the ground, it means the uh, altitude is 0, and it should be a value less than 500 as well. And I have defined the GPS, the IMU, gyro camera here, and the telemetry data. Again, for all these data points, I've enforced the data types. Only for timestamps, I have included an extra class. So this field validator is a Pydantics decorator, and this class method basically what this does is it checks if the timestamp value has time zone info. If it's in the ISO H.X01 format, then it will be considered and the value will be returned. If not, an error will be raised. So this is all for this particular video, and in the next video I'll explain how I set up the conception layer that's in PostgreSQL. So I have already worked on the bronze and the silver layers, but I will finish with the gold layer and explain the whole process in the next video. Okay, thank you.